When we were kids, we were taught how to use the standard algorithm to multiply, but we weren't taught why it works or what it actually means. We were just taught magic zeros. These days, we're doing a whole lot better with our kids using the area model to teach multiplication. Let's take a look. All right, so we'll start here with 26 times 14. So 26 times 14. Now, if your child looks at this and says 26 times 14, and they say 26 plus 26 plus 26 plus 26 plus 26 plus 26, and they keep going 14 times, I actually would recommend you don't stop them. Let them go ahead and do that, because what that's doing is that's helping them to realize what multiplication actually means. And hopefully at some point they're going to realize, I don't want to do that. Hopefully at some point they're going to realize that's not the math they want to do. They're going to stop on themselves and say, you know what, there must be a better way. And as soon as they stop and think there must be a better way, that's a time when we can say, okay, let's have a conversation. If I try and tell the students, don't do it that way, that's not the most efficient way, you know what they're going to want to do? They're going to want to do that more, honestly, just to show that they're right and we're wrong. And if you look at their notes from class, or if you look at their work from class, you may notice a different way of multiplying than you've seen in the past. So that's what I want to show us now. It's called the area model, and I'm going to show us how we can think of multiplying 26 times 14 using an area model, or using a rectangle as we think through here. And I'm going to look at that rectangle and think about if this was a rectangle and I was trying to find the area, I could just do 26 times 14. Of course, I could bring out Siri and I could bring out Alexa and just ask them. And what I might want to do is think about, is there a way I could break up or decompose these numbers, 26 and 14? And I could think of 26 as 20 and 6, and I could think of 14 as 10 and 4. And again, I'm just decomposing or breaking those up into tens and ones. And as I think about this, I could say, okay, if I process into this piece and into this piece, if I broke this large rectangle up into 20 and 6 and 10 and 4, what I could do is I could find what is 20 times 10, and 20 times 10 is 200. Many students find their 10 tables pretty easy, kind of trying to find this, breaking it down. It's called a partial product as we're looking into here, because it's part of the entire product. And then 20 times 4 is 80, and then 10 times 6, well, that's 60, and then 4 times 6 is 24. So then from here, all I need to do is simply add 200 plus 80 plus 60 plus 24. I'm adding those partial products, and those partial products right here are going to all add up together to be the full product. And if I add those together, I get 364. So this is what we're teaching our students in schools these days about what multiplication actually means. Don't worry, we are actually going to get to that multiplication, that standard way that we use it. It's called the standard algorithm. We're going to get there, but we're going to start here. So we don't want to minimize the use of thinking about these rectangles, and I want you all to have a deeper understanding of what they actually mean. Again, ultimately, we are going to get kids to do 26 times 14. 6 times 4 is 24. 4 times 2 is 8, plus 2 is 10. We're going to use this zero. I'm going to talk about that zero another time, but I'm going to recommend that we don't call it a magic zero, because there's nothing magic about it. But really, it's going to be 1 times 6, and then 1 times 2. Coming over to here, we get 364. Now, what I do want to come back to this magic zero, there's nothing magic about it. It's really not 1 times 6. It's actually 10 times 6, and 10 times 6 is 60. That's why we put a 0 there as a placeholder. And it's really not 1 times 2, it's 10 times 20, which is going to be 200 as we're thinking through these different pieces. Now, as I look, hopefully you can clearly see that if I do the standard algorithm, I get 364. If I use the area model, I get 364 also. So something I always like to ask when I'm talking to children, talking to students about, hey, what do we notice is the same? And first off, we do see the answer is the same. But what I would always like to challenge and say, I see 104 right there. There's 104 right there. Where is the 104 up here? Where do we see 104? And I like to give children a chance to kind of look at that and say, where do I see 104 up here? Is there 104? And in time, students begin to realize, or many students begin to realize, that 80 and 24 together makes 104. So then if I pushed a little more, I could say, okay, well, what does that mean, though? What is the 80 and 24? Where did we get the 80 from? Where did we get the 24 from? Well, in this particular case, 80 is from 20 times 4. And then 24 is 6 times 4. Down here, 4 times 6 was 24. We use that same number right here. So there's the 24, there's the 24, there's a 24, 4 times 6 in here. And then 4 times 20 was 80, and there's the 80 in here, so 4 times 20 was 80, and we carried, some of us talk about that carrying the 2, that carried 2 is an extra 20 there. So we're beginning to see how all of these fit together.